instructor Brendan is sick today, so I'm going to be filling in for him. We're going to be doing lab 4, which is an SN2 reaction. We're going to be reacting 2 chloro, 1 ethyl, 3 methyl cyclohexane with hydroxide, and we're going to form 2 ethyl, 6 methyl cyclohexanol. We're going to be using DMSO because it is an aprotic solvent, as you can see under our hot tips for the lab today. And remember that SN2 needs a good nucleophile. You guys can refer to your lab manual for the procedure. Does everyone understand?
Kiera, I don't really get what we're doing. Could you show me?
Well, Kieran, this is our reactant, and as you can see, the ethyl group and the chlorine group are both wedged, and they're both in the same plane, and the methyl group is dashed.
So are we reacting it with this?
Yeah, hydroxide.
I'm not getting the right product. Do you know what I'm doing wrong?
Are you using a good leaving group?
Yeah, I'm using chlorine, so it should be a good leaving group as it is a weak base.
Are you using a good nucleophile?
Yeah, I'm using hydroxide. It's a very strong base. It's one of the best nucleophiles.
Are you using DMSO?
Do you not smell the DMSO?
Yeah, that does smell.
We're definitely using an aprotic solvent for an SN2 reaction.
It's on heat, and heat favors elimination.
Oh.
Kieran, try doing it at a colder temperature and see if you get the right product.
All right, one last try. That's it. That's the right product.
Perfect. That's perfect, Kieran. When the nucleophile came in, the OH, it took the leaving group and it inverted the stereochemistry like it should in an SN2 reaction.
I finally understand SN2 reactions.
Perfect.
Okay, class, did everyone get the right product?
Yeah!
Good! So I'm going to show the mechanism for you guys. So we're going to have chlorine as your leaving group, it leaves, and then the OH with the minus charge comes in. And remember, that's all in one step, and then we get our product with the inverted stereochemistry at where the leaving group was. Some final notes to remember for your next midterm. SN2 happens in one step. There's no carbocation formed. The rate is equal to K times the leaving group times the nucleophile, so it's bimolecular. The stereochemistry gets inverted, as you all saw, and it prefers primary over secondary and no tertiary forms because of steric hindrance. Needs a good leaving group, that's why we use chlorine. It has to be cold, and it needs a good nucleophile, which is a strong base, and that's why we use the hydroxide today, and the aprotic solvent, which is why we use the DMSO.